So an alkene that has two double bonds is considered a diene. An alkene with three double bonds is considered a triene, and anything above three double bonds is a polyene. So let's talk about how do we name your diene and your trienes, right? Now, in your regular alkene, where you have En, that's gonna be if it's two double bonds, it's gonna be you replace En with Adiene, adiene. If it's three double bonds, you replace En with a triene. Let's look at an example. So of course, we're gonna look at this example, and of course, you need to number so that your double bonds have the lower set of numbers. But in this case, we have a double bond at both ends. So it doesn't matter which direction I number, left, right, left, you'll end up with the same set of numbers. So 1, 2, 3, 4, 5, 6 carbons in my longest chain. Um, if I were to so your double bond is between 1, 2. So we pick number 1. Second double bond is between 5 and 6. We pick number 5. If I were to number in the opposite direction just to show you that it doesn't make a difference, you would still end up with the same thing. 4, 5, 6. Still 1, 5. Because you're red, double bond is between 1, 2. Double bond is between 5, 6. So when you name this, we must locate where the double bonds are. There's a double bond. Let me take out the red numbers. So with a left, right, left, you'd have gotten the same set of numbering. So identifying the double bond. 1, 5. Remember, you separate numbers with a comma. It's 1, 5. I have 6 carbons in my longest chain. So 1, 5 hex. Instead of writing En, we write Adien, and don't forget your E. So it's 1, 5 hexadiene. Okay. So when you write your regular alkene name, hexene for example, this part, if it's a diene, is replaced with Adien. Let us name another one. This time let's pick something with a substituent on it. All right, cool. So let's number, right? 1, 2, 3, 4. So when I number with gold, my double bond is at 1, 3. And how I know that? Here's the double bond is between carbon 1 and 2. You choose the lower number. Double bond is between 3 and 4. Pick the lower number 3. My substituent is on 2. It's a methyl group, right? Cool. What if we decided to number in the opposite direction? What would happen? Just because. Now, my double bond is still at 1, 3, right? But where's my substituent? It's on 3. It's on 3. So clearly, I'm not going to pick blue, I'm going to pick yellow. Because with blue, yes, you end up with the same 1, 3 as with the yellow, but look where the substituent is. The substituent is on 2 when we do gold, right? So always remember, you're paying attention to the key is your double bond. The double bond, your numbers so the double bond get the lowest set of numbers, which is what is happening here. Lowest set, same thing, right? But here, the substituent is on a lower number. Of course, you're going to go with that. The lowest set of number right across the board is what you always look for. Remember, with your alkenes though, the double bond rule. So since the double bond is the same whether I'm blue or yellow, right? The only reason we're not numbering in the blue direction is because the substituent has a higher number. So my recommendation, if you're ever naming, do your numbering right, left, right, and then take it from there, right? And also pay attention to make sure that the substituent has the lower number, after you've taken care of the double bond. The double bond rules, don't forget that. So let's name using our gold numbering. So on carbon 2, I have a methyl group. So you write 2-methyl. You name the substituent, right? Just like you would do for regular alkene or alkene. Then you have to identify where the double bonds are. There's one between 1 and 2. There's one between 3 and 4. Take the lower set of numbers, 1 and 3, and it's going to be 4 carbons in my longest chain. So it's going to be bute. Instead of writing En, you write Adien and the E at the end. So 2-methyl 1,3-butadiene. All right. Let's try something with 3 double bonds. Let's see how we would name this. All right. You will number your chain 1, 2, 3, 4, 5, 6, 7. There's a double bond between carbon 1 and 2. We take 1. There's also a double bond between 4, 5. We take 4. And there is a double bond between 6, 7. We take number 6. Now, let's see if we number in the opposite direction, if it will make any type of difference, all right? So let's go. Let's do blue. 1, 2, 3, 4, 5, 6, 7. What's going on with blue? So let me take yellow out, just so we can focus on blue for a second. With blue, double bond is between 1 and 2. We take number 1. Double bond is between 3 and 4. We take number 3. Double bond is between 6 and 7. We take number 6. So, what are we doing? Are we blue or are we yellow? We're definitely blue, because that's the lower combination of numbers. When I do yellow, the second double bond is on 4. When you do blue, it's on 3. So our correct direction to number is right to left. So let's name this. First, locate where the double bonds are. There's one at 1, one at 3, one at 6, 7. So you take 6. 7 carbons in your longest chain. So it's going to be hept, right? And instead of writing En, you write Atriene, and of course E. So hept atriene. Let's name this last one here. This is a ring. For this ring, remember in your ring, the double bond gets 1, 2. For this one, it doesn't matter where you number. You're still gonna get 1 and 4. So double bond is between 1 and 2. We take 1. Double bond is between 4 and 5. We take 4. And it's 6 carbons in your ring. 1, 2, 3, 4, 5, 6. So cyclo, because it's a ring, hex adiene. And that's how you name your dienes, trienes. At your level, the most you'll see is 2 double bonds or three double bonds.